Hello and welcome back. In this episode we're going to take overview of electronic parts needed when building a CNC router and also making a test spin of those, so stay tuned. If you're new to my channel, this is all about designing and building this 50-meter cruising sailboat from very scratch. And we're in the very beginning of this process right now, so you're welcome to the party, and push that subscribe button first and that bell as well to be informed of the new episodes. Meanwhile, I've also made video series of turning my current sailboat to electric sailboat, and there's a 9-part series on the YouTube already, so you can check that out from that link there. And if your heart is even more into sailing and do-it-yourself stuff, consider becoming a Patreon. The link is just down there, and also you can support this channel, this whole project, by purchasing these amazing shirts from the store. These are good quality, eco-friendly, 100% cotton shirts, and they're awesome, and the logo looks really nice. And also you can follow the Facebook and Instagram pages to keep informed between of these videos. So links on those are in the description as well. And this video is the first one after I gained the 1000 subscribers, so thank you everyone, and let's get into it. As for the electric sailboat conversion I mentioned, we're just making the set of 5 of these electric boat conversion kits that fit into the Volvo Penta MB2/50S sail drive and Golden Motor 3 kW BLDC motor. So if you're interested to turn your boat to electric with this combination, contact me. We have a few of these still available for purchase, so you can hit me with a comment or email to this arctic.seacamel@gmail.com. The price is not confirmed yet, but I believe it's something between 250 and 300 euros. But let's start with a small situation report of the shed and the boat. Within the last few months I've been really trying to get my hands in the building site for the shed. It has been much more difficult than I thought, and so I haven't really found the place yet, but there is a couple of good opportunities right now. But in the next few weeks I believe there's something happening with this issue. Also, I'm just about to order the shed itself. I talked with the structural engineer a few weeks back, and we came in the conclusion that most efficient and easiest way is to actually buy a ready-to-go, very lightweight steel framed and tarp tent like shed, and making a light insulation under that as a independent structure. Actually, the insulation layer under there will cost almost the same as the whole tent, so dreaming of a warmer climate. So the idea, of course, is that the outer layer will take care of the rain, the snowfall and wind and all of that, and the box inside a tent will just keep it warm enough with the work there. The target is that the shed should be ready during the summer, so I can start building the boat in the late summer or in the fall. We have to remember that this shed is actually one of the biggest investments within the whole project. Everything else should be smaller expenses over time. After I push the order button, there's really no turning back anymore. So fingers crossed that everything goes smoothly with this. As for the boat plans, I sent the current plans to Mr. Tanton a few weeks ago, and he's trying to take a look at them from the structural side, and in the near future I should get back some information of certain measurements for me to go forward and finish things like where the masts should be and the keels and everything like that, and what kind of structure should there be. Now I think we should concentrate on that CNC router, which is the thing that I've been working on quite closely in the last few weeks. But let's first check the CNC frame we did a couple of months ago. So the frame you see here is a very heavy steel frame that now has been machined in very high precision to fit the linear rails and racks you see here. After the last video, I have purchased the racks, and there's now mounting holes machined into those racks as well, and they seem to fit perfectly. And last video I also put the legs together, but after that we came in conclusion that they not may be needed after all, because the purpose of this machine is to cut pieces from large plywood sheets. It's actually feels easier to use the machine when it's just on the floor, so you don't have to do any heavy lifting to get the plywood on top of the machine. But I will still stash the legs for later use if we decide someday to use them. So as you can see, the frame is now complete. Now I'm just waiting to move it from the workshop to the temporary place where I can put the machine parts together, and we'll come back into that in the next video, I believe. So during the last couple of months I've been ordering quite a lot of stuff, and there's just a part of it, and now there should be almost everything here. Basically the only thing that is still missing is the main profile for the gantry, and it should be on its way right now. So after that I can really go and finish and measure everything, and it should all be good. There is still some small things that I have to look into, but mostly it should be quite okay. But let's dive into the plans and see what's changed since the last revision. So the obvious change here is the rack drive. So this has been now redesigned completely, and now there is this, in the picture you can see this blue thing that is moving part that now it drives this pinion against the rack, and it has spring tension into it, so it flexes a bit if something dirt or something goes between the rack and the pinion. And it also has this belt reduction, which gives more precision and less forces against the motor, so this should be necessary to not to directly drive the pinion with the motor, but have some kind of reduction between there. This is all also here. There's a couple of custom shafts to be made with some bearings I have here. The whole unit, that moving unit, is held by these bronze bearings, and there's also this Teflon plate that is held against too, and it should work well. For that pinion drive there's going to be just normal ball bearings, so the shaft will go through both of these and have this pinion down there. So these are all here now, and I can finish the plans with these. And of course the motor itself, which is this one, there is the belt tensioning system and the motor mount included that part as well. And another bigger design, not change, but the part that the design has gone forward is the Z-axis area and hold this thing. So if we put this linear rail carriage in its place right here, like so, and here we have the Z-axis ball bearing thing. So you can see that the level of these isn't really the same, so I had to raise this rail bit to be able to put these on the same level on the other side, so these won't fit 100% without this kind of little fiddling, but now there's these spacers under these linear rails and it should work fine. But on the other hand, that Y-axis, I didn't do it like that because I didn't want any additional thickness from that main beam, so I decided to move the ball screw on top of the profile so that I didn't have to do this thing with that X-axis as well. I think it's easier to build and maintain that way. Addition to all of this, there is also now places for sensors. There's these inductive limit sensors that will sense when the machine is on its limit, so it won't hit anything. Now there should be places of all of these. There are still some things to look into, but they are not that big anymore. I have to check all the screws and screw holes and things like that. Now all the mechanical parts should be here, except for the cable carriages. After the plans have been completed, we should be able to start manufacturing the aluminum plate parts, which is basically all of these extra things here that are custom made. So I think that was all from the mechanical side. Now I think we'll jump to the electrical side and take a look how all of that works. So here we have the test arrangement as called as the Frankenstein board. All the electric parts have now connected in here, and I just wanted to, of course, test everything that they work before I install them anywhere, but also I wanted to make sure that I order big enough cabinet to fit all this stuff in, and of course it's going to be the biggest one I could find. But there is still not all the stuff in here yet. There's going to be, for example, some DIN racks for fuses, connectors, cable organizers and all stuff in between. It's going to take quite a lot of space. And of course, this inverter is going to be installed in the cabinet as well. I now try to explain everything easily so that you could understand how this kind of CNC machine actually works. So we can think of the system as a combination of 2 or more inputs and 2 or more outputs. And if we start from this button here, this is now the power input for all these machinery here. So of course it works with electricity, and the first input is the electric power that runs everything. And from this switch, the power is then distributed to all the parts. And these 6 boxes here are different power supplies that supply power for different devices. So the big ones in here, they are power supplies for each of the motor and the motor controllers. So the power comes here and is distributed for this motor power supplies and through them into the motor controllers that actually run these 4 motors here. And from this power source we also run the actual spindle that you can see right there. It has this inverter power supply, and then there is this water pump that provides cooling water for that spindle as well. So all of these are powered by this one source. Then there is these additional 2 power supplies over here that provide power for this motion controller and all the other smaller stuff. For example, this probe receiver right here. But yeah, the power is the first input. The 2 main outputs are, of course, the spindle that does the dirty work for us, and the second output is these motors over here that provide the movement for the whole machine. So they are kind of the output side of this machine. But in addition to the power, we need some kind of information how to move the machine, and then there is this second input, which is the computer right here. So the computer is connected via the Ethernet cable into that motion controller, which is kind of the brain of the system. There's different approaches into controlling the CNC machines, but I decided to go with this little fancier option that should be a little bit more reliable and has quite a good amount of different inputs and outputs. From the computer we get the CAD drawing, that is what we want to make, and turn it into G-code, which is then provided for the motion controller, and this controller then creates electric pulses, which are basically the steps that these motor controllers then tell the motor to move. So the power supply power to run this thing, and the computer provides signal to guide where the motors should go. And that's the basic idea here. It's not that complicated actually. These motors here are stepper servo motors. They are quite hefty ones. These big ones are 12 Newton meters and the smaller one is 3 Newton meters. And these 3 drive the X and Y axis and this smaller one runs the Z-axis, which is the up and down movement. And stepper servo is different from basic stepper motor in a way that it has the integrated encoder with them that provides information for the motor controller where the motor is actually spinning. A normal stepper is just a dumb piece of equipment that just does what it's told to do, and it doesn't provide any feedback. But with this thing, the motor controller actually know how many steps the motor has taken and if there has been any steps missed, because in high loads the stepper motor can be stalled and kind of lose steps, and then the accuracy is lost. With these kind of motors that shouldn't happen. And I've learned that also they should be quite a bit more energy efficient. They shouldn't heat that much because motor controller doesn't need to hold the motors still just in case. These are a little bit from the hefty side of this kind of hobby motors. The additional input I'm going to have with this machine is sensors that provide information for the motion controller and the computer that where the machine is actually going. So these kind of things are going to be all over the machine, and when the machine approaches these, it gives signal that now that machine it's on its limits. And you really should have limit switches of some kind in every CNC machine to avoid mistakes and possibly breaking your equipment. And another control we're going to have with this is to control the spindle. This inverter power source will accept signal from the motion controller to control the speed of the spindle from the computer, so you don't have to always put on the spindle by hand. There is also, of course, risks with that because this is very powerful device. But yeah, now when everything is connected, I think we should make a test spin with this machinery. So first thing we're going to do here is to put the power on, and I will just rotate this emergency switch to power it up. And now all kinds of lights appear here. You can see everything is on, there's all green lights, and also this motion controller is on. And now I have already connected the Ethernet cable into the computer, and we should start the software. And here we have a blue light that tells that there's a link between the computer software and the motion controller. Like so. And now everything should work with these arrow buttons here. So if we start with the X direction, in this direction, we can push the button here. And you can see the motor is spinning when I press here. And the Y is these two, and they should rotate in the opposite directions because they are of course on the either side of the machine. Like that. Finally, there is this Z-axis, which is used by page up, page down buttons here. I just make a little setting here, make it move a little faster, maybe you can even hear it. Like that. And everything works like a charm. It's really amazing that you can basically order from eBay a bunch of stuff and make a machine like this. Yeah, let's try to load an example program from this software. Now you can see there's this some kind of holders, whatever they are, example program. And now when I push the cycle start here, oh, I should mention that this software actually came with this motion controller. I ordered it from the CNC Drive Hungary, and it feels very high quality equipment, and it wasn't in the cheapest possible, but I wanted to have something a little better. But yeah, let's push the cycle start, and you should see on the computer screen right here how the machine is moving and how the motors are spinning when I start this program, like that. It's quite fast now, so I have not yet calibrated anything with this, so it's just basic settings. just like that, program is ready. Now I can push go to 0 and it should 0 itself. And everything works like a charm. It's just amazing, and I'm so pleased all of this, and everything has been going very smoothly and no real problems here. But yeah, now I have already ordered the cabinet, and I'm going to order soon all the additional electrical connectors and stuff we need to make this look nice and clean and safe. So that's it, everything works. Alrighty then, it has been like Christmas for many weeks when all these boxes have arrived, and cats love the boxes though. Now it's almost complete in a way, but now there should be only a few bits and pieces left to arrive, and then we will be ready to go. Now when all the mechanical parts are already here, I can really make the final adjustments for the CNC plan and also the manufacturing parts, because there has to be all the holes and threads and stuff accurately in the plans so we can make them quickly and efficiently. But yeah, that's it for this video. As you can maybe see, I'm here at the lake, and this part, this very spot, is the place we are going to sail in a couple of months, and spring is definitely coming. We'll see you hopefully soon, and if you've been enjoying this video, please leave a like, and if you have anything to ask or comment, put some comments down below, and remember to subscribe, of course, and check out my Facebook and Instagram pages as well. Yeah, but have a great spring, everybody. Be safe and take care of each other. Bye.